In addition to calculating crystal orientations, we can also determine crystal grain boundaries using the Jack-in translation stage of the MWL120 system. We currently have a polycrystalline tungsten sample on our 3-axis goniometer. In the real-time image, we can see a diffraction pattern. Let's do a quick histogram, 5 seconds, on this point. Now we can auto-detect points. Index the pattern, and we have our orientation solution. Now we can store this solution as orientation 1. As I said, this is a polycrystalline sample, so if we translate the sample to the side, we will find out that the diffraction pattern changes as we move to the side. So let's collect a histogram at this new point. Again, it will be just a 5-second collection. As before, we can auto-detect points and find the solution. And we can now save this orientation as orientation 2. We can compare these two orientations to each other. The misorientation report shows us not only the orientation of each of these grains, but it also tells how far apart they are in our different angles, and a sum misorientation angle. This is very useful when we have to know how far apart neighboring grains are. We can continue to translate the sample to the side, and you will see that there are yet more grains on the sample. And each time we pass from one grain to another, we see that the diffraction pattern changes. The ability to translate the sample, and therefore look at different parts of the sample, is extremely useful. In some crystals, you can see optically where grain boundaries are, but in many materials, using the MWL120 X-ray detector system is the best way to determine where grain boundaries are.